Hello, ladies and gentlemen. Today we're going to be taking a look at pyramids and cones and their volume. So for this, you're going to need your flip chart notes or a place to write those formulas, as well as something to write with, and of course a calculator because we're going to be doing some calculations. So let's first start by opening up your little foldable guy to the pyramid page. Now on one side you have written your surface area formulas, you have all the surface area stuff. On the other side of that staple you need to write some volume. So this is a very important formula for volume of a pyramid. Remember, this is what our pyramid looks like. It has one base, it has triangles that kind of slope up the side. There's a lateral height or an L, a slant height there on the side, and then there's an H height up and down in the center of that pyramid. So with that in mind, here's what you should write down, that volume equals 1/3 capital B times H. Capital B times H, 1/3 BH. Now notice that capital B is in there, and remember that capital B is going to represent the area of the base. So the base area, and the H represents the height, and that's going to be inside of our pyramid now, not slanted on the side there. So that H height, as you see there in our diagram, and the B is the base area, so whatever's on the base of that pyramid. So let's put one example into your notes right where you put that formula or near where you put that formula. Let's draw this picture. We're going to go ahead and find the volume of this pyramid, and we're going to round our answer to 2 decimal places. Now notice on the base of this pyramid we have a hexagon. That is a 6-sided shape. So we're going to need to think about that base as well as what's happening there with the volume, and it involves a height. So remember, our formula for volume is 1/3 capital B H. So capital B is the area of the base. So before we can find this volume, we're going to need to find the area of whatever's happening on the base there. And then remember, in our case, it's a hexagon. So I'm going to go ahead and draw that hexagon to the side here so I have a little bit more writing room. We have a 6 for a side length, and remember, to find the area of a hexagon, we're going to divide them into little triangles. So if the whole side down there was 6, then that means that this little piece here was just 3. Oops, I kind of put that in a bad spot. Let's try that again. So this little piece down here is 3. And we need to find this height over here in order to find the area of that triangle. So to do that, we're going to use a sine, cosine, or tangent, or a special right triangles, Pythagorean theorem, whatever we need to find that height. Now, because this is a hexagon, we know that there are 720 total degrees. I got that by taking 6 minus 2 times 180. There's 720 total degrees. That means in each corner or each angle of our hexagon, there would be 120 degrees. Dividing that by 6. Except in the corner of our little triangle here, there'd only be 60 because that's half of 120. So in order to find the height of our triangle, you could use special right triangles. I think I'll use my tangent here. I'll do tangent of 60 equals x over 3, opposite over adjacent. So the tangent of 60 from a calculating device, then times 3. So tangent of 60, and then take that answer times 3, and I have my x is 5.196, so roughly 5.2. So that means the height of my triangle here is 5.2. Well, what's the area of that one little triangle then? The base of the triangle is 3 times the height of the triangle, 5.2. Divide that by 2 because that's the area formula for a triangle. Base times height divided by 2. So we'll take that answer, which is 7.8. We'll take that answer now times 12 because there would be 12 little hexagons inside, or 12 little triangles inside my hexagon. So I get a total base area of 93.5. Now that's just the area of the base, the hexagon base. So to find the volume, we needed that. That was the hardest part. We have to find the area of that base. and then we're going to pretend like we're filling this pyramid up. We're going to fill them up with water or little cubes, and we're going to need to do this volume formula. It says volume equals 1/3 times the area of the base, which we just found, 93.5, times the height of the pyramid, that's h height, that's straight up and down, that was given to us as 8 in our picture. So if we go ahead and multiply those three numbers, the 1/3 times the 93.5 times the 8, we should get a volume of 249.4. And remember, this is cubic centimeters now, not square centimeters, because we're filling this little guy up with cubes of units, okay? Cubic units. So that's how we calculate the volume of a pyramid. Let's take a look at that cone formula, or volume of a cone. Same idea. You have that one base, so it's going to look similar. Volume equals 1/3 area of the base times the height, but in our case, the area of the base is a circle, so it's pi r squared times the height. So this is the formula that we would use for cone, 1/3 pi r squared height. And you're going to need to write this on your cone page, and then we're going to do one example right after this. So here's our cone example. Let's draw that picture. We're going to find the volume of the cone. To find the volume of a cone, 1/3 pi r squared h. That's our formula. So if I start plugging in what I have, 1/3 pi, what's the radius? Well, that's 5. Give it to me right here. The radius of my cone is 5. And then what's the height of my cone? Be careful, the height goes straight up and down, not to be confused with the slant height there of 13. So we don't actually have a height number. We're going to need to figure that out. To figure out this height number right here, perhaps Pythagorean theorem would be a good choice. We do 5 squared plus x squared equals 13 squared. 5 squared is 25. 13 squared is 169. Subtract x squared equals 144. Square root, x is 12. So that tells me the height of my cone, that straight up and down height, is 12. And so if I plug all those numbers into my volume formula here and I go ahead and multiply all those in my calculator, it would be 1/3 times pi times 5 squared, which is 25, times 12. And we go ahead and type that all in, and the volume becomes 314.2 approximately. And we'd say feet cubed for volume. So that's how we use that cone formula to figure out his volume. It's very similar to the pyramid formula, but it all involves using that area of that base times the height times that 1/3. Okay? So keep that in mind as we continue to practice using these formulas in different contexts. Thank you for taking good notes.